Okay, so you may start when you're ready.
Ba't ganun? Pabalik nga pag zona. Good morning po. Ang topic po namin ay measurement of earthquake magnitude versus intensity. Next po. Magnitude versus intensity. Ang magnitude ay ang sukat ng seismic energy ng isang lindol na name-measure ng seismograph. Ang intensity naman ay ang sukat ng lakas ng pagyanig. Depende sa nararamdaman ng tao at sa epekto nito sa mga istruktura tulad ng bahay at sa natural environment. Next po. Calculating earthquake magnitude. An earthquake's magnitude is a number that allows earthquakes to be compared in terms of their relative strength. Earthquake magnitudes were calculated for decades using a method created by Charles Richter, a seismologist headquartered in California. Richter calibrated the magnitude scale using seismograph from earthquakes that occur in the San Andreas fault zone. The amplitude of the greatest waves recorded on a seismograph of the earthquake and the distance to the epicenter of the earthquake are combined to determine the Richter magnitude of an earthquake on seismograph. The greatest amplitude seismic wave, the tallest one, is recorded in millimeters. The epicenter distance must also be considered. Next po.
The ranking earthquake intensity. The magnitude of an earthquake is not the same as its intensity. Earthquake strength is a classification based on the impact of an earthquake in a specific location. As a result, each earthquake generates a range of intensity levels, ranging from the strongest near the epicenter to zero at a distance. The modified Mercalli earthquake intensity scale is the most often used earthquake intensity scale. An shortened version can be found on the U.S. Geological Survey Earthquake Hazard Program's Modified Mercalli Intensity Scale page. Next po. The table shows approximately how many earthquakes occur each year in magnitude range and what the intensity might be at the epicenter for each magnitude range. Sa magnitude 0 to 1.9 daw po ay the average number per year is 1 million. Ang modified Mercalli intensity ay wala at sa description is micro not felt. Sa magnitude 2.0 to 2.9 naman daw po, ang average number per year is 1 million. Ang modified Mercalli niya intensity is 1. The description is minor, rarely felt. Sa magnitude 3.0 to 3.9 naman daw po is the average number per year is about 100,000. Ang modified Mercalli intensity niya naman po is 2 to 3. Ang description is minor, noticed by a few people. Sa magnitude 4.0 to 4.9 naman, average number per year is about 10,000. Modified Mercalli intensity niya is 4 to 5. Ang description is light, felt by many people, minor damage possible. Sa magnitude 5.0 to 5.9 naman daw po, average per year niya is about 1,000. Modified Mercalli intensity niya naman po is 6 to 7. Ang description naman po is moderate, felt by most people, possible, broken plaster and chimneys. Sa magnitude 6.0 to 6.9 naman daw po is average number per year niya is about 130. Tapos modified Mercalli intensity niya is 7 to 9. Ang description naman daw po is strong damage, variable depending on building construction and substrate. Sa magnitude 7.0 to 7.9 naman daw po is average number niya per year is 15. Ang modified mercalli intensity niya is 10 ay 9 to 10. Ang description naman daw po ay major extensive damage, some building destroyed. Sa magnitude 8.0 to 8.9 naman daw po, the average number per year is about 1. The modified mercalli intensity naman daw po is 10 to 12. Sa description naman po ay great intensive damage over broad areas, many building destroyed. Sa magnitude 9.0 and above naman daw po is average number per year is 1. Ang modified Mercalli intensity naman daw po is 11 to 12. Ang description nila naman is same sa 8 points, magnitude 8.0 to 8.9. Next na po. The following tables give intensities that are typically observed at location near the epicenter of earthquake of different magnitudes. Ito daw po yung makikita sa malapit sa epicenter ng earthquake. Sa magnitude 1.0 sa magnitude 1.0 to 3.0 naman po, ang modified Mercalli intensity is 1. Ang modified Mercalli intensity 1 is not felt except by a very few under especially favorable conditions. Sa magnitude 3.0 to 3.9 naman daw po, ang modified Mercalli intensity niya is 2 to 3. Ang modified Mercalli intensity ng 2 is felt only by a few person at rest, especially on upper floors of buildings. Sa number 3 naman po ay felt quite noticeable by person indoors, especially on upper floor of building. Many people do not recognize it as an earthquake. Standing motor cars may rock slightly, vibration similar to the passing of a truck, duration estimated. Sa magnitude 4.0 to 4.9 naman po is ang modified Mercalli intensity niya is 4 and 5. Ang modified Mercalli intensity scale ng 4 is felt indoors by many, outdoors by few during the day. At night, some awaken dishes, windows, doors disturbed, wall make cracking sound, sensation like heavy truck striking building, standing motor cars, rock noticeable. Sa modified Mercalli intensity 5 naman daw po is felt by nearly everyone, many awakened, some dishes, windows broken, unstable objects overturned, pendulum clocks may stop. Sa magnitude 5.0 to 5.9 naman daw po ay ang modified Mercalli intensity niya is 6 at 7. Ang modified Mercalli intensity po ng 6 ay felt by all, many frightened, some heavy furniture move, a few instance of fallen plaster damage light. Sa modified Mercalli intensity 7 naman po is damage negligible in buildings of good design and constructions, slight to moderate in well-built ordinary structures, considerable damage in poorly built or badly designed structures, some chimneys broken. Sa magnitude 6.0 to 6.9 naman po is ang modified Mercalli intensity niya ay 7 and 9. Ang modified Mercalli intensity po ng 7 is damage in buildings. Sa 7 po ay damage negligible in buildings of good design and constructions, slight to moderate in well-built ordinary structures, considerable damage in poorly built or badly designed structures, some chimneys broken. Sa modified Mercalli intensity naman po ng 8 ay damage slight in specially designed structures, considerable damage in ordinary substantial buildings with partial collapse, damage great in poorly built structures, fall of chimneys, factory stacks, columns, monuments, wall, heavy furniture overturned. Ang modified Mercalli intensity naman po ng 9 is damage considerable in specially designed structures, well-designed frame structures thrown out of plumb, damage great in substantial buildings with partial collapse, building shifted off foundation. Sa magnitude 7 pataas naman po at ang modified Mercalli intention niya is 8 or higher. Yung modified Mercalli 10 ay some well-built wooden structures destroyed, most masonry and frame structures destroyed with foundation rails bent. Sa modified Mercalli 11 naman po is few if any masonry structures remain standing, bridge destroyed, rails bent greatly. Sa modified Mercalli intensity 12 naman ay damaged total lines of sight and level are distorted objects thrown into the air. Yung next naman po.
I'll be discussing the earthquake hazards. Next. It is an unavoidable geological fact takes place due to earthquake occurrence and resulting into ground motion effects. Areas and zones of earthquake hazard can be defined based on the past seismicity. Studies integrated with other geophysical data are useful to forecast the destruction, which helps engineers to design earthquake-resistant structures. The overall goal is to understand and depict the area motions which can damage the building and other structures. It also thus helps to design future structures for their survival during an earthquake. The primary requirement for seismic hazard studies is the strong ground motion data obtained from near the earthquake occurrences. In many cases, it is collapsed buildings that cause the most harm during an earthquake. Buildings should be constructed in ways that make them unlikely to collapse. The strategies that engineers have developed include having sufficient flexibility in the structure to absorb shaking during an earthquake. We also have misconceptions about earthquake hazard. Earthquakes really pose little direct danger to a person, but people can't be shaken to death by an earthquake. Some movie scenes shows with the ground suddenly opening up and people falling into a fiery pits, but this just doesn't happen in real life. Earthquake hazard includes the ground shaking. The first main earthquake hazard is the effect of ground shaking. Buildings can be damaged by the shaking itself or by the ground beneath them settling to a different level that it was before the earthquake, or subsidence. Buildings can even sink into the ground if soil liquefaction occurs. Next is tsunami. A number of waves may be produced and they can travel long distances at high speeds to flood far off shores. The height of a tsunami varies and may be affected by the seafloor depth, shape, and other factors. Next is landslides and rockfalls. On steep slopes and in mountainous areas, large earthquakes can set off many landslides, rockfalls, or avalanches. These can damage buildings, towns, or roads in the path of the landslides. Other geological hazards that may affect parks include areas of karst, caves from the erosion of soluble rocks such as limestone, mining, subsidence, sinkholes, and earthquakes. Weather events such as heavy rainfall, flooding, temperature extremes, or high winds can affect the stability of geological. Next is subsidence and lateral spreading. Next slide po. Subsidence or lowering of the ground surface often occurs during earthquakes. This may be due to downward vertical displacement on one side of a fault and can sometimes affect a huge area of land. Coastal areas can become permanently flooded as a result. Lateral spreading occurs when sloping ground starts to move downhill, causing cracks to open up that are often seen along hill crests and riverbanks. Next is the liquefaction. It is the destabilization of sand or soil when groundwater is forced out from between grains during the shaking of a moderate or strong earthquake. It occurs under a building. It may start to lean, tip over, or sink several feet. The ground firms up again after the shaking has stopped. It is a hazard in areas that have groundwater near the surface and sandy soil. Any buildings in the path of these surface waves can leap or tip over from all movement. The ground shaking may also cause landslides, mudslides, and avalanches on steeper hills or mountains, all of which can damage buildings and hurt people. Next is permanent ground displacement. During large earthquakes, the ground may permanently shift to a new position, up, down, or sideways. This change in the location of the ground, which also tilts the ground, may cause disruption of roads and utilities and in coastal cities, submergence or emergence of harbor facilities. Even ground shifts of less than a meter can cause serious disruption of infrastructure. Next is fires. Broken electrical wires and natural gas pipes commonly set off fires during earthquakes. To compound the problem, the water supply may also be disrupted by earthquake damage, making it impossible to put the fire out with water from fire hydrants. Last is the earth rupture. During most earthquakes, some rupturing of the earth's surface takes place along the fault trace. This produces a fault scarp which may have up to several or vertical displacement. This can disrupt roads and utilities, and any buildings on a fault that ruptures may undergo extensive damage. Rupture of the earth during an earthquake may also occur on secondary faults. Earthquake-induced rupture of the earth's surface may also take place in weak zones of surface sediment that fracture and spread. If enough spreading of a ruptured surface layer takes place, it can be classified as a landslide.
Earthquake prediction. Scientists are a long way from being able to predict earthquakes. A good prediction must be accurate as to where an earthquake will occur, when it will occur, and at what magnitude it will be so that uh, people can evacuate. An unnecessary evacuation is expensive and causes people not to believe authorities the next time an evacuation is ordered. Next po. Where an e- where an earthquake will occur is the easiest feature to predict. Scientists know that earthquakes take place at plate boundaries and tend to happen where they've occurred before. Because earthquakes are the result of the release of stress or strain that builds up as Earth's tectonic plates move and grind against each other. Earthquake-prone communities should always be prepared for an earthquake. These communities can implement building codes to make structures earthquake-safe. Although some regions around the world are definitely more prone to earthquakes than others, it is not possible to accurately predict where earthquakes will occur. Next po. When an earthquake will occur is much more difficult to predict, since stress on a fault builds up at the same rate over time. Earthquakes should occur at regular intervals. Kagaya po nitong nasa figure. Sa California daw, ang earthquake na may magnitude 6 o pataas ay dumadating kada 22 years. Kaya ang mga scientists predict na may dadating na earthquake in 1993, pero dumating daw ito ng 2004, 11 years late. Next po. Signs sometimes come before a large earthquake. Small quakes called foreshocks happen in the same place as the larger earthquake that follows. However, many earthquakes do not have foreshocks, and small earthquakes are not necessarily followed by a large earthquake. Often the rocks around the fault will dilate as microfractures form. Ground tilting caused by the buildup of stress in the rocks may precede a large earthquake but not always. Water levels in wells fluctuate as water moves into or out of fractures before an earthquake. This is also an uncertain predictor of large earthquakes. The relative arrival times of P waves and S waves also decreases just before an earthquake occurs. Makikita ang time interval ng P waves at S waves sa seismogram na recorded sa seismograph. Nakikita din dito ng mga scientists kung gaano kalayo sa location nila nangyaring earthquake, pero di nila alam kung saang direction. Also, P waves travel faster than S waves. Yun lang.
Seismicity and earthquake prediction. Seismicity is the study of how often earthquakes occur in a particular area, which types of earthquakes occur there, and why. So in the United States, the areas with most frequent experience earthquakes are in the coast of California, Oregon, Washington, and even in an island of Alaska. While in the Philippines, yung 6 of the 7 largest Philippine earthquakes ng 19th century na may magnitude of 8 or higher were in Mindanao. These areas are near the Cotabato Trench and the southern portion of the Philippine Trench. So as we talk about seismicity, we also talk about the hypocenter, which is defined as the location below the Earth's surface where the earthquake starts. At ang epicenter naman is defined as the location directly above it on the surface of the Earth. Yan. Earthquake epicenters compiled on a map shown ay yung global basis niyan ay yung most earthquakes na nag-occur around the rim of the Pacific Ocean. At yun yung mga mountain of Southern Asia from China to the Middle East, which is yung epicenter ay natitrace din sa mid-ocean ridges across the floors of the ocean. It is because nearly all earthquakes occur on faults, determining seismic risk on a final scale largely consists of identifying, mapping, and studying active faults in each state or region. However, many active faults are hidden, either because any scarps they form at the surface have been eroded or covered by sediments, soil, and vegetation, or because they are blind faults. So, yung hidden fault, hindi yan basta na-identify or nalolocate hanggat hindi nagkakaroon ng earthquake sa lugar na yon, o di kaya naman hindi napapag-aralan pa yung seismic waves na naganap para ma-identify yung location at kung anong type of fault motion ang nangyari. So, ang information used to determine the seismicity of an area ay yung frequency of earthquakes in the past, yung historic records, yung nakaraang earthquake or lindol na nangyari. Tapos yung location of known active faults, seismologic data collected on recent earthquakes, at yung tectonic setting of the area, stress and strain being experienced by the crust in that area, underground geologic layers and structures in that area. So, based on this information, yung seismic risk of a particular area ay hindi na ay nakaka-quantified lang statistically. However, no scientific method has yet been developed that can predict precisely when is the next earthquake in a specific region will happen, where it will happen, or what will be the magnitude or intensity of the earthquake. As of now, yung seismicity, we can identify which areas on Earth will undergo major earthquakes in the coming decades and centuries. We can delineate which areas on Earth are at risk for the most powerful types of earthquakes and map the coastal areas that are most at risk of being inundated by a tsunami, but we cannot pinpoint in advance the date or location of the next major earthquake. So, yun pa lang yung ang napapag-aralan about seismicity. Wala pang further study kung ma-identify ba yung mga bagay-bagay about sa earthquake sa isang lugar.
Sir, tapos na po, sir.
Okay.
Hindi lang po kami
Wala. Okay, so um, naisan niyo na ba yung copy ng report?